All right, let's talk our way through 4.1 number 3. This shouldn't be too bad. So I'm trying to figure out what the half-life of something is, right? That's the thing I'm ultimately searching for. So I'm going to throw a little line underneath that. I have a radioactive material. That causes me to think that P of t is P0 e to the RT, or causes me to think about the kind of half-life function model. Either way. Now, what is loses 25% of its mass in 10 minutes? This is where my like reading comprehension is going to come in pretty handy. I have a tendency to draw little arrow diagrams when they tell me stuff like this, right? So I'm going to say 10 minutes. Maybe I'm going to label my arrow 10, I guess. So how much did I start with to begin with?
P naught.
Yeah, sure. P naught, I guess. And after 10 minutes, how much do I have?
P naught divided by 4.
Close. How much did it lose?
P naught times 3 divided by 4.
Perfect. I have 3/4 of it left. And this is honestly where things go the most awry. It's like, all right, if you're converting a percentage in your head into a fraction, and then you're trying to do something with that fraction, you're pretty liable to have one of those kind of maybe 4 or 5 moving pieces get away from you, right? So what you need to do is be just a teensy bit careful about like rereading what it's asked for and just confirming that you have the right thing. So I tend to reread with a little skepticism anything that I've written down. So if I had to rephrase this to myself, I'd say after 10 minutes, 3/4 of it is left. And then I'd go up and say, okay, so after 10 minutes, I feel like I got the 10 minutes, loses 25%. Is that the same thing as 3/4 left? Yeah, okay. But that reread is a really important thing that we don't really teach in English class because you don't have to do it in English class, right? Because you're not trying to synthesize really complicated information into a different form, right? You're just trying to like figure out generally what the author's more or less about, right? In this case, you're going to do a lot of that, like bounce back and forth between the words in the problem and the equations that you're writing on the page. So this thing is really phrased again is about P of 10 is 3/4 P naught. Does that make sense? So even though I took this information out of the problem, this is basically me drawing a picture of the situation. Like it's a little bit loose to call this friggin' thing a picture, but that's what I always try to start with in any word problem at all. I'm going to start with drawing a picture. You guys notice that I always draw a spring doodle even if I never use it? Like, if you hand a mathematician a problem, the first friggin' thing they're going to do, no matter what it is they're going to try to draw a picture or diagram, some little bullshit with arrows. Like, they're always going to do that, and it's because it gives us a framework to place our thinking on. Plus, it's less scary to have something drawn on the page than it is to have a fully blank page. All right, so what do I do with this information? I know P of 10 is 3/4 P naught.
And then I plugged it into the power, or I set it equal to the power model, but I plugged t is equal to 10 into it.
Good, yeah. So this is like on the situation hand and on the model hand, right? On the other hand, I know that if I plug 10 into the model, I should get this. So I have P0 e to the 10r. And this is going to let me solve for r, basically. So I'm going to multiply both sides by 1 over P naught. I probably should note that P naught equaling 0 would be a problem.
But it can't. Because how can you have something with zero quantity?
I don't know. I mean, how much radioactive substance do you have right now?
Well, actually, the funny thing is back in when they first started testing nuclear bombs, basically we all got a little bit of radioactive material in us because of winds.
Yeah, I highly recommend a. There's a really fun podcast that I like called The Dollop. A couple of comedians do history. One of them researches a story and then reads it to the other guy who has no idea what the story's about. And one of their episodes is about the radioactive Boy Scout, a kid that, in trying to earn the nuclear engineering merit badge, called a smoke alarm company and ordered from them something like several thousand broken smoke alarms, out of which he took a large amount of, I think, cesium, and then created a basically working nuclear reactor in his backyard and gave himself the biggest case of radiation poisoning. So my hope is the answer is none. However, smoke alarms exist, so you probably have some. Um, all of that was to say that the P of T is identically zero function is actually a solution to this in the case that you started with nothing. Does that make sense? Okay. Long-winded explanation aside, this is one option. The other option is that we can divide by P0. Then we can solve this thing. So we get something like R is the natural log of 3/4 over 10. Okay, then what do I do with that? Well, I'm going to plug that into my model, right? So I'm going to get P of T is P0 E raised to this kind of horrible little number times T. Okay, great. I'm done, right? Why not?
What was our original quantity? What's our P naught? I don't even know if there is a way to solve that though.
I don't think there is. I don't see one. I mean, they didn't give me very much information. Like, if there were more sentences here, I'd be more worried. But there's like one sentence here. I feel like I used all the information in there. What was the question they were actually asking, though? What was the question they asked me?
What's your half-life?
Oh, they didn't even ask for the model. Shit. How do I figure out what the half-life is?
Well, it's the amount of time it takes for it to lose half of its substance. So maybe if you do like P naught divided by 2 and then set it equal to the model and then solve for T.
Hells yeah. Yeah, exactly. So take your model, set it equal to P naught over 2. Notice the P naughts are going to cancel. Solve this thing out. You guys got this. Algebra. Answer goes in the box. Okay, quick question. What units is the answer in?
Minutes?
Dude! Exactly. The problem, the original question was in minutes, ergo the answer is in minutes. Cool. Questions, things on this? Should we do another reading comprehension exercise? Let's do another one.